All right, thanks for joining me again. Today we're going to be hitting some things with ionic formulas a little bit further, but today we're going to be hitting with transition metals. We've been skipping those for a large part for most of the year, but today we're going to get into how to write and name ionic compounds using those transition metals. So the learning objectives are the same as they were before for our last one. We're still writing ionic compounds, but this time we're specifically doing transition metals instead of just looking at groups 1 and 2 in terms of our metals. So the transition metals, our main vocabulary. And our transition metals, again, are those that make up the largest part of the periodic table across the middle. So we've been kind of skipping those up to this point because the transition metals don't tend to follow the same patterns as everything else. So as a reminder, this is where we start using the D block. Everything else is in the S's and the P's. In the transition metals, the new electrons always go into d orbitals, and if we think about that in the Bohr model, that means we're not putting them on the outside outside shell. They're going basically into the one before that, so they don't tend to follow the same patterns as most of the other ones. So since these don't follow a pattern, we can't really use the periodic table to find the oxidation number. Just as a reminder, for example, if we wanted to find the oxidation number of something in group 1, that's easy. Everything's got an oxidation number of +1 because they all are going to lose their 1 electron. When we get over here into the transition metals, that pattern doesn't exist, and so we need to be able to look things up effectively. The information has to be given to us to be able to use it. So since some of these a number of these elements can exist at different oxidation states. What that means is some of them might be +2 or +3. We have to use Roman numerals to tell which version of the transition metal we end up using. And I'll give you an example of this in just a moment. And a note here, these are not isotopes. So Roman numerals, just as a quick review, if you don't know them, this kind of shows you how 1 through 6 would look. We use kind of the letter I for ones. We put multiples of them. V is for 5. If you put a 1 in front of the V, that's like 1 before V, so it's 4. If you put a 1 after the V, that's 1 plus 5, which is 6. So just as an example, iron usually has a +2 or +3 ion. Again, there's nothing on the periodic table that tells us that. We just have to accept it in a chart or something, and we would note that by using the Roman numerals such as shown right here. So iron with a 2 or iron with 3 would be how we would end up noting those. So whatever's in parentheses, here's the easy thing. It tells us what the oxidation number is. So if we need to write a formula, a lot of the work's already done for us. It's actually somewhat easier than what you've been doing before. So as an example, iron 2 oxide, these would be the oxidation states. So iron would have a +2 because the 2 in parentheses tells us what it is. Oxygen would be -2 because oxygen's, again, always -2. So that part of it doesn't change. We're not changing how we do that. Again, oxygen's over here in uh, group 16, kind of covered up a little bit. So since it's in group 16, it's going to be -2. Oxygen's always going to be -2. And so what we're doing today has nothing to do with the nonmetals. It has to do simply with the metals and understanding that that number corresponds to what's in parentheses right here. Okay, so let's see what we got next. If we want to write the formula, we would still kind of do the crisscross method as you've already done. So that we would bring the 2's down. If we wanted to put them, try to figure out how to kind of write the correct formula. Again, the 2 goes here, that 2 goes here. And remember, we don't leave 2 and 2 because we need to be able to reduce that. So we wouldn't write it as Fe2O2. We end up reducing it down. And so the correct formula for iron 2 oxide is going to be FeO. I'm going to do a couple of examples on the next couple of slides here. So an example would be chromium chloride. Going through our steps again, first step is to write symbols. So chromium, chlorine. Again, I don't even have to look anything up for chromium. Its oxidation state is +3. Chlorine, if I go to my periodic tables in group 17, it's -1. All right, so we've got those terms. If we crisscross, I take the 1, put it here. I take the 3, I put it there. And so I want to get chromium with a 1, but remember, we never write the 1. We leave it just kind of blank. And the chlorine is going to end up getting a 3. And basically, we're done. So again, oxidation, crisscross, reduce if we need to, and that's going to give us the formula. I know I'm moving pretty quickly here, but you can always stop and rewind if you need to get your notes. Another one, so iron oxide, final kind of example here. So again, write my symbols. Iron is Fe. Oxygen's O. Write my oxidation numbers. Iron is +3 because that's what that means. Oxygen, go back to my periodic table, is in the -2 column. Once we've got that, we crisscross our terms. So the 2 is going to end up here. The 3 is going to go here. Remember, we don't take pluses or minuses with us. We're just using this as a kind of a tool. So we're not literally taking the -2 and putting it here. We're just taking the 2. So Fe2, and then the O is going to get the 3. And then that's our formula for this one. All right, so what's next? Excuse me. All right, naming compounds is a little bit tricky because we have to name them with the proper Roman numerals. So we have to figure out which metal we're talking about. So going back to the first example, we'd have to figure out if it's iron 2 or if it's iron 3. We need to work backwards to be able to do this. So for an example, Ni3N would be called nickel nitride, but we need to figure out which nickel is it. And to figure this out, we'd have to work it back because whatever nickel it is going to have to balance out the nitrogen. All right, so let me show a real quick example of this. To work this out, if I've got Ni3 with an N, basically if I use my periodic table, I know that nickel is -3. Excuse me, nitrogen is -3 because of where it is on the periodic table. And so if we crisscross backwards, then that tells me that the 3 that I got down here would have come from the oxidation here. And since there's no exponent down here, that's a 1. So it's very likely that that should be a positive 1. That's the way that those two things would be able to balance out. So this has to be nickel 1. And I would write it, put that in parentheses this way. Let's go ahead and example, a couple more examples and wrap things up. So we, again, just kind of have to work backwards with these. So if I had Ni and S to try to figure out which version of nickel, again, we've got. So let me write my symbols out. So what the first thing I really need to do is figure out what do I know? Again, I know the oxidation for sulfur. Sulfur's in the same column as oxygen, which is going to be -2. All right, so notice that in my formula up here, these two things are balanced out. So that means I'm in a 1-to-1 ratio. So for every nickel, there's going to be a sulfur. Well, if sulfur has a -2 charge, the only way I can get a 1-to-1 ratio is if nickel balances it out perfectly, which would have to be a +2 charge. All right, because otherwise I would have to have numbers down here. So the only way I never have numbers down here is if my oxidations are equal and opposite. So since I know sulfur is -2, then nickel would have to be +2. So if I were to write the name of this out, it would be nickel 2 sulfide. Let me write it out. Okay. I think I got one more, possibly. Yeah. All right. So we got an iron oxide. If we can again do this, so iron. If I write these out, so I got iron 2, oxygen 3. So let's remember what else do we know? We know that oxygen would have to have a -2 here. So work backwards. So that means the 3 would probably need to go here to make sense. So we're just kind of working backwards from what we did to begin with. So this tells me which version of iron that I'm working with. And if I needed to name this, this would be iron 3 oxide. Right. So you should have some stuff to practice with this and get a little additional help if you need it, but those are the basics. Summary slide, transition metals may have multiple oxidation possibilities. We need to use Roman numerals to indicate which of those transition metals we're working with. And again, if we've kind of trying to name it, the formula is going to have needs a little bit of math and a little bit of logic to figure out which oxidation state we're going from a formula backwards into a name. Good luck, enjoy your practice, and I'll see you next time.